Hi, in this video, I will be showing you problem number 11 of chapter 14, section 3. If f of xy equal to 16 minus 4x square minus y square, find f sub x, the partial derivative of f with respect to x at 1, 2, and the partial derivative of f with respect to y at 1, 2, and interpret these numbers as slopes. Illustrate with either handwritten sketches or computer plots. First off, we will identify what this f of xy equal to 16 minus 4x square minus y square surface is. And then we will interpret we will find out the partial derivatives at the point 1, 2 and interpret them. So f of xy is given to be 16 minus 4x square minus y square. We'll call it equation 1, and we call f of xy as z as well. So z equal to 16 minus 4x square minus y square. This is an elliptic paraboloid because z is linear and we have square in x and y. So it is a paraboloid. It's elliptic because you have, if you plug in z equal to 0, you're going to get an ellipse on the xy plane. So it is an elliptic paraboloid opening downward. Xy trace is obtained by setting z equal to 0. So if we set z equal to 0, we get an ellipse, and yz trace by setting x equal to 0, we get a downward parabola on the xz plane, and on the yz plane as well, by setting x equal to 0, we get a downward parabola. So on the xy plane, we get an ellipse. On the yz and xz plane, we get downward parabolas. So it is an inverted downward paraboloid opening downward with an elliptic bottom on the xy plane. So that is the surface. Now we are going to find out the partial derivative. We are asked to find the partial derivative fx at 1, 2 and fy at 1, 2. So when x equal to 1 and y equal to 2 at this point, what is z value equal to on the surface? So z is given by 16 minus 4x square minus y square. If you substitute x and x equal to 1 and y equal to 2, here we get 16 minus 4 minus 4, which is equal to 8. So when x equal to 1, y equal to 2, z equal to 8. So the point P, 1, 2, 8 lies on the surface. And that is where we are finding the partial derivatives, which are the rate of change of the tangent line, the rate of change of z with respect to x and y. So we are examining the slopes of the tangent at the point 1 to 8 at this point on the surface. So f of xy equal to 16 minus 4x square minus y square. So to find the partial derivative f of x at 1, 2, we are going to keep the y constant and differentiate with respect to x. So fx equal to negative 8x, and fx at 1, 2 is obtained by substituting x equal to 1 here. So it is negative 8 times 1, which is negative 8. So we have a negative slope of the tangent at 1, 2. Similarly, we have to get f sub y, which is the partial derivative with respect to y. For that, we are going to keep x as a constant. Similarly, to find f sub y at 1 comma 2, keep x as constant and differentiate with respect to y. So fy of xy equal to negative 2y. Substituting 1 comma 2 or y equal to 2 here, we get negative 2 times 2, which is equal to negative 4. So both partial derivatives with respect to x and y are negative. So the slope of the tangent line at the point 1, 2, in the direction of x and in the direction of y, both are negative. So we'll graph the surface and we will interpret what this exactly means. What do we mean by this negative value for fx and fy? Now we shall interpret these values which are f of x, fx at 1 comma 2, which is equal to negative, and fy negative 8, and fy 1 comma 2 equal to negative 4. Fx at 1 comma 2 equal to negative 8. When finding fx at 1 comma 2, we actually consider the intersection of the surface with the plane y equal to 2 with the paraboloid, with the surface. So the intersection of the plane y equal to 2 with the surface. So we get a curve of intersection. So we are going to substitute y equal to 2 into the surface equation, z equal to 16 minus 4x square minus y square, where y is replaced by 2. So 16 minus 4x square minus 2 square, that will be equal to 12 minus 4x square, which is a downward parabola in the xz in the plane y equal to 2. This is a downward parabola on the plane y equal to 2, which is parallel to xz plane. Now we are going to do a rough sketch of the surface z equal to 16 minus 4x square minus y square. And then we are also going to give the intersection of the planes y equal to 2 and x equal to 1. And we are going to find out the intersection with the surface, which end up as downward parabolas. So x-intercept of this graph of this surface is obtained by setting y equal to 0 and z equal to 0, which gives us 16 minus 4x square minus 4x square equal to 0. So x square equal to 4. This gives us x equal to plus or minus 2. The surface intersect the x-axis at 2 and negative 2. Same way, y-intercept is obtained by setting x equal to 0 and z equal to 0. Which gives us 0 equal to 16 minus y square. So y square equal to 16 or y equal to plus or minus 4. So the surface intersect the y-axis at plus 4 and negative 4. Then z-intercept is obtained by setting x equal to 0 and y equal to 0. So we get z equal to 16 when we substitute these values into the original equation of the surface. So as the tangent is examined at the point 1, 2, 8, we are more interested in only in that part of the surface in the first octave, because x, y, z are all positive, and we are going to draw the tangent only at that point. So we are interested only in that part of the surface in the first octant, which contains 1 to 8. So we are not going to graph the entire surface in this problem. So consider only the part of the surface in the first octant. So I'm going to do a rough sketch here. This is y and this is z and this is x, that is coming out of the board is always the x-axis. So we are going to do two slices. One for y equal to 2, that will be for fx, the partial derivative with respect to x, is obtained by setting y as a constant, and in this case we are determining at the point 1, 2, 8, so y equal to 2 and x equal to 1. So we are going to first slice at y equal to 2. So it's only a rough sketch. So the z coordinate is not going to be covering 16. The point of intersection of the surface with the z-axis is 16. So I'm going to only roughly scale it. So it's not exact point on the z-axis that I'm going to show. So x is intercepted at 2, y is intercepted at 4, and z is intercepted at 16. So let's graph this in the first octant, and this is what we get for the surface in the first octant. Now we slice it at, so as I said, 16 is placed roughly. We are going to slice it at y equal to 2, where we are going to graph the tangent. So we are going to see an intersection of the plane with the surface. So it's going to be, you're going to see a slice similar to the slice that you see on the xz plane. It's kind of similar to that slice in the plane y equal to 2. So this is what we are going to get as a slice at y equal to 2, which is the curve of intersection is a downward parabola. It is this part. Then at 1 to 8 we are going to draw the tangent. So that is roughly 1 to 8 in that point. And we are drawing the tangent at 1 to 8. So fx at 1 to we found out to be equal to -8, which is the slope of the tangent line at the point P in the direction of x. So as x increases, z decreases. That's why we get that value to be equal to -8. So z decreases. Clearly it is seen in this graph. Same way we will make a slice at x equal to 1, and we are going to consider a plane at x equal to 1 and find out the intersection of that plane with the surface in the second graph. So roughly 16 is placed on the z-axis and 2, 4 on the x-axis and the y-axis. Complete the surface. It's a rough sketch. It's not a beautiful graph. And then we are going to make a slice at x equal to 1. So we consider the intersection of the plane at x equal to 1 with the surface. Now we are going to get something similar to what you see on the YZ plane. You are going to get a slice parallel to that figure, parallel exactly similar to the figure on the YZ plane. So we get a graph which is again a downward parabola. This is the slice that we get, intersection, and this is the part of the curve which is downward parabola. Here we are going to take 1 to 8 and draw the tangent at that point 1 to 8. So which is again decreasing slope. As y increases, z is decreasing. That is what fy, f sub y, partial derivative with respect to y is. With fy at 1, 2 is -4 at p. So as y increases, z decreases, showing that the slope is negative in the y direction. So in this problem, we sketch the graph we actually found out the point 1 to 8. Then we drew the tangents fx and fy at that point and interpreted what these values fx and fy mean in the context of the surface. Hope this video helps.